Good morning everyone and welcome to my YouTube channel. So here today we are going to be solving our polynomial equations. So what is the method that we are going to be using? So we are going to be using our method of testing certain values which will give us a 0 when we replace for x. So these are what we are going to call the possible rational solutions. So the possible rational solutions, these are values which we are going to call our R, which are the possible rational solutions, should be equal to what we are going to have our P over our Q, where P is equal to A0 over our Q is AN. So A0 is the number that is without x, so that's why it's A0, because it doesn't have x. So we are going to have what are the possible factors of 4. So the possible factors of 4 are plus or minus 1, numbers that can enter into 4 without leaving a remainder, plus or minus 2, plus or minus 4 itself. Then we have over, we are going to have something like the AN, which is our 3. What are the possible values that can enter into 3 without leaving a remainder? So we have plus or minus 1 and plus or minus 3, like that. So these are the values which we can use to more like be able to put them there, and they will be able to give us a certain solution. So now what we are going to do is that let's first try our positive 1 there. So if we try our positive 1, so that means to say first possible solutions. So possible solutions are such that we are going to have something like this. We have a plus or minus 1, we have a plus or minus 2, we have a plus or minus 4, like that. Then combine them. 1 divided by 1 is still 1, so it scatters for this. 2 divided by this is still 2. So we are just going to have something like 4 over at least a 3. This is something different. We have plus or minus 4 over 3, like that. Also, plus or minus this 2 divided by 3 is a possible value we can use. So these are our possible values. So now let's see which one will give us a 0. So if it is the power 3, this one is very simple. Let's try a plus 1 using the synthetic division. So we are going to have something like this. For the synthetic division, we have our x to the power of 3, x to the power 2, x to the power 1, x to the power 0. So just look at the highest power on your polynomial. If it is power 3, then this will begin from power 3, reducing until to the power 0 there. Then we are going to have, let's say we try our positive 1 to see whether it's a factor, meaning to say when we replace it there, it should give us a remainder of 0. So if we put 1 here, for the equation that is having 3x cubed, so for x cubed it has got a 3, then for x squared it has got 8, so we are going to put 8 here. Then for x it has got negative 15, so we are going to have negative 15, like that. Then for x to the power 0, this we are going to have a positive 4, like that. So then what we are going to do is that here we are going to multiply, here we are going to add. So drop the 3, we have 1 times 3, it will give us 3. Then 8 plus 3, that will give us 11. Then multiply 1 times 11, this will give us 11. Add negative 15 plus 11, negative 15 plus 11, this will give us a value that is equivalent to negative 4, like that. So let's put our negative 4 here, multiply 1 times negative 4, it's negative 4. 4 plus negative 4, that's a 0. So if it gives you the remainder of 0, it means to say it is a factor. So this is a factor. So x is equal to 1 is a factor. So what we are going to have is that, what we are going to have for that problem is that we have The equation is saying 3x to the power 3. Let us just lift this. 3x to the power 3 plus 8x squared plus 8x squared. If x is equal to 1, it means to say it can be taken here. So we are going to have our x minus 1 should be equal to 0. So if x is equal to positive 1, it means to say it can be taken on the other side to become x minus 1 is equal to 0. So this is what we are going to write, x minus 1, then multiply by whatever you get here. So what we have gotten here is such that we have a 3. So the highest power was 3. So this quotient will reduce by 1. So we are going to have 3x squared, then we have plus 11x, then we have minus our 4 like that. So this is what we have there. So this is what we have from here. What we are going to do is that you should factorize this. So factorizing this to find the value. So we have a 3x squared plus 11x minus a 4 there. So we are going to use the usual approach. Our product should be equal to AC, which is equal to our A is 3. So this is our A, this is our B, this is our C. So our A is equal to 3 times our C is equal to negative 4, which will give us a negative 12 like that. Then we are going to have our sum should be equal to B, which is the coefficient of B is 11. Then our factor, two numbers, which when we add them, they are going to give us a positive 11. When we multiply them, they are going to give us a negative 12. So these numbers are positive 12 and a negative 1 like that. So if we multiply these, they will give us negative 12. If we add, they will give us positive 11 like that. So what we are going to do is that we are going to put these values here. So we have a 3x squared, then we have plus, where there is 11 we are going to put 12x, then we have minus our x there, then we are going to have minus 4 like that. So this is equal to a 0 like that. So what we are going to have is that let us factorize in parts. So 3 is common here and x is also common. So we are going to have our 3x, then open brackets. If we remove 3x, we are going to remain with our x there. Then we have plus 12 divided by 3, that's a 4. So x is taken out. So that is what we have. Then here we factorize. We are going to have a negative 1 is common. Open brackets, negative 1 divided by x, that gives us positive x. Negative 4 divided by 1, negative 1, it will give us plus 4 like that. So this should be equal to a 0 like that. Then if what is in the bracket is the same, we are going to say our x plus our 4. Then we also have what is outside, we have a 3x minus 1 like that. So this should be equal to 0. So now to find the values, we are going to have our x plus 4 is equal to 0, or our 3x minus 1 is equal to 0. So we are going to take our 4 this side, we are going to have our x is equal to negative 4, or we are going to take our 1 there, we are going to have our 3x should be equal to positive 1. Then we divide by 3, we divide by 3. Our x value should be equal to 1 over our 3 like that. So this is our x value. So our first x value is this, our second x value is this. So we have found the first value that we found, our x, it was equal to positive 1. So either x is equal to positive 1, or x is equal to 1 over 3, or our x is equal to, we are going to have a negative 4 like that. So these are our values of x. Let's look at the next problem. Let's look at our second one. So we are going to have something like our p over q, which is equal to our a0 over a n, which should be equal to, so our a0 in this case is this one, our an, which is the one having the highest power. So this is the same as the possible roots are such that we are going to have a plus or minus 1 for 8. So we have plus or minus 1 there. So we have plus or minus 1, or we have a plus or minus 2. All these can enter into 8, and a plus or minus 4 Then we also have a plus or minus 8, like that. Then let's look at the an. So we are going to have a plus or minus 1, or we could have a plus or minus 3, like that. So all the possible factors, or rather, yes, possible factors should be equal to plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, like that. Then we continue like that. We are going to have a plus or minus. So if you divide 1 divided by 1 is still 1. Then you have a 2 divided by 3, because divide by 1 doesn't change anything. So we have 2 divided by 3. So another possible value is a plus or minus 2 over 3, like that. Then the other possible value is a 4 divided by 3. So we have plus or minus 4 over 3. Or we have a plus or minus 8 over 3. So remember, when we have our 1, 2, 4 there and 8, this is first dividing with the plus or minus 1 there. So these are just the possible values that can be used. So let's get into it. Let's try a positive 1 and see whether it's a factor or not. So it's still power 3. So we are going to have x to the power 3, x to the power 2, x to the power 1, and x to the power 0, like that. Then we have, let's try our positive 1. So we are going to put a positive 1 there. Then find out what is the coefficient of x to the power 3. So we have a 3, 7, and negative 22. So we have a 3, 7, and negative 22 there. Then last but not the least is the constant, which is our negative 8. So we are going to put negative 8 and see. So here we are adding, here we are multiplying, here we are adding. So drop the 3, we are going to get a 3. Then 1 times 3, it will give us a 3. 7 plus 3, this will give us a 10. Multiply 1 times 10, this will give us 10. Negative 22 plus 10, negative 22 plus 10, this will give us a negative 12. So we are going to have a negative 12. 1 times negative 12, we are going to have negative 12. So the last digit is a negative 20 as your remainder. If it doesn't give you a 0, it means to say it's not a factor. So now you can also try to see whether if you put negative 1 here, whether it will work or not. Now for this problem, negative 1, you can try it, but it's not working. So let's move to a factor that is working. So the next value, you can try a negative 1, but it's not working when you do this. So the remainder should be a 0. So let's move on to 2. Let's try our 2. So the values that are there, we have a 3, we have a 7, we have negative 22, we have negative 8. So here you are multiplying, here you are adding. Drop the 3. So we have 2 times 3. This will give us a 6. 7 plus 6, this will give us 13. Multiply 2 times 13, which will give us a positive 26. Add negative 22 plus 26, this will give us a positive 4. So we are going to get a positive 4 like that. Then multiply 2 times 4, this will give us a positive 8. Negative 8 plus 8, this will give us a 0. That means to say you have factorized that one. So if this is the remainder, it means to say 2 is a factor. So if this is the remainder, that means to say 2 is a factor. So if you have your x is equal to 2, it means to say when it's taken here, it will be your x minus 2 is equal to 0. So this was the value that was used. Therefore, what we are going to have is this. After looking at that, we are going to have something like this. Our equation, which was our 3x to the power 3, then we have plus our 7x to the power 2, then we have minus 22x, then we have minus 8 should be equal to we are going to write our first factor, which is our x minus 2. You multiply it by, since the highest power here is 3, it will reduce. So we have a 3x squared, then we have plus our 13x, then we have plus our 4, like that. So this is how we write the converted form. Just multiply whatever is your quotient, which is the result, times this other one. So let us factorize. So we have a 3x to the power 2, then we have plus 13x plus a 4, like that. So this is equal to 0. So our product is equal to AC, which should be equal to a 3 times 4, like that. So this should be equal to 3 times 4 gives us 12. Then we are going to have our sum, which is equal to b, which is equal to, so b has got the coefficient of positive 30. Then we have our factors. So our factors are numbers which when we multiply them they give us 12, and if we add them they are going to give us 13. So in this case a 12 and a 1 would work. If you add this they will give you 13, if you multiply they will give you 12. So let's replace. So we have our 3x to the power 2 plus, where there is 13 we are going to put our 12x plus, where plus our x, then we have plus our 4, which should be equal to 0. So factorize in parts. So here 3 is common, then we are 3x, then we are going to have our x plus 12 divided by 3 will give us 4 there. Then we are going to have plus 1 is common here, so we are going to have our x plus our 4. Then put them in brackets. So we have the x, we have x plus 4. The other bracket should be 3x plus 1, like that. So therefore we can rewrite it. We can just solve it to say x plus 4 should be equal to 0, or our 3x plus 1 should be equal to 0. Let's take the 4 this side. We are going to have our x is equal to negative 4, or we are going to have our 3x. We take the 1 equal to that, we are going to have negative 1. Then we divide over our 3 there. We are going to get a x is equal to negative 1 over 3. We also have our x is equal to negative 4. The other thing is that we have also found that our x, which was our first intercept, is equal to 2, or rather the first solution, which is equal to 2. If they want you to factorize, all you have to do is that just take this the other side, take this the other side, also take this the other side, which would be, if you are factorizing, the equation was 3x squared, then we had plus 7x squared minus 22x, then we have minus 8, sorry. So this should be equal to, if we take the 4 there, we are going to have our x plus 4, then we are going to multiply our, if we take the value here, we are going to have our x plus 1 over 3, then we are going to have also our x minus 2, like that. So this is how we do that one. So this is how we factorize if we were asked to factorize. So there should be a bracket there. So this is how we are going to be factorizing if they give us a question that is similar to that. Just get your values like that. Let's look at our last problem. Let's say we have this problem. So doing the same, our p over q, which is equal to our a0 over our an. So our a0 is 13, so we are going to say plus or minus 1, and also plus or minus our 13. We divide by our an, which is the coefficient, is 1, so we just have plus or minus 1. So the possible roots, or rather the possible solutions will be such that we are going to have just a plus or minus 1. Whether you divide it by 1, it's still plus or minus 1, or plus or minus 13. So let's try whether a plus 1, whether it's working. So the highest power is 4. So we are going to have our x to the power 4. x to the power 3, x to the power 2, x to the power 1, and finally we are going to get x to the power 0 there. Then our factor is such that we have a positive one. Then what we are going to have is that, what are the values? So the values in front of x to the power 4 is 1, x to the power 3 it is a negative 6, so we have a negative 6, we have a 22, positive 22, we have a negative 30, we also have a positive 13, like that. So what we are going to do is that we are going to drop this value. So here we are multiplying, so we drop the 1, then add here. So 1 times 1, it will give us 1. Then add negative 6 plus 1, it will give us negative 5. Then multiply 1 times negative 5, it will give us a negative 5, like that. Then multiply. We are going to have a 22 minus 22 plus negative 5. So it will be 22 minus 5, which is equal to a positive 17. So we are going to put a 17 there. Then from there, multiply. We are going to have a 17. 1 times 17. This will give us a positive 17. Then add negative 30. Negative 30 plus a 17. This will give us a value that is equivalent to negative 13, like that. Then multiply 1 times negative 13, it will give us a negative 13, like that. Then add 13 plus negative 13, it will give us a 0. So as long as the remainder is equal to 0, that means to say it is a, so this is our remainder, it means to say this is a factor. So x is equal to 1 is a factor. So that means to say for the equation that was equivalent to our x to the power of 4 minus 6 x to the power of 3 plus our 22 x to the power 2 minus 30x, then we have plus our 13 should be equal to, we are going to have our x. So if x is equal to 1, it means to say when it's taken this side, it will be x minus 1 should be equal to 0. So we are going to say x minus 1, then we have times. So we are going to write this other one. So we have, this will be our x since it's 1. So we are going to have our x. The power was 4, so it will be reduced by 1. So we have x to the power 3. Then we have minus our 5, x to the power 2. Then we have plus our 17, x, like that. Then we have minus our 13, like that. So we have found one value of x which is equal to 1. Now, just because you have used 1, it doesn't mean to say you cannot use it again. No, you can use the same value, but the way it works is that when you use the value again, if it is not another factor, it means to say it will not work. Now, why we use that is that sometimes an equation might be factorized to say x plus 1, you have power 2. This means to say this is the same value of x at one point. That means to say the value is repeated. So what you do is that you can try out the same value as many times as possible, but if it stops working for that equation, it means to say it is no longer a factor. So we have found 1, x is equal to 1. Then what we are going to do is that we are going to do it again. So we are going to have something like this. So we have, now it is x to the power 3. So we are going to have our x to the power 3, x to the power 2, x to the power 1, x to the power 0, like that. Then we also have down here, we have the multiply, then add. So the value, we are going to have 1, then we have our negative 5, then we have our positive 17, then we have our negative 13, like that. So what we are going to put here is that we have a 1. You can use the value even 3 times. As long as it's working, it means to say it is still a factor, of which if it works again, it means to say you have something like x minus 1 squared, meaning to say the value is repeated as one of the solutions. So you are going to have something like this, where you are going to drop the 1, it will be here. So 1 times 1, it will give us 1. Negative 5 plus 1, negative 5 plus 1, this will give us a negative 4. So we are going to put negative 4 there, then multiply 1 times negative 4, it will give us negative 4. Then add 17 plus negative 4 is the same as having 17 minus 4, which is equal to a 13. So we are going to have a positive 13. Then we are going to have 1 times 13. This will give us a positive 13 like that. When you add negative 13 plus 13, that's a 0. So this is how we do that. Now, if the power was 3, it means to say it shall be reduced to, this will be your x squared minus your 4x plus 13. So the power just reduces by 1. So as you can see, when it has worked, it means to say we have, if x is equal to 1 at 2 points, it means to say your x value is equal to, when you take the 1 the other side, it will be minus 1 should be equal to 0 when you do that. So now this means that the equation that was equivalent to x to the power of 4, x to the power of 4 minus our 6x to the power of 3 plus our 22x to the power 2 minus our 30x plus our 13 should be equal to, so we have the roots repeated, so we have our x minus 1, another one it's x minus 1 like that. Then we have this quotient, which is our x squared minus 4x. Then we have plus our 13. So that means to say, if the equation, if 1 is not working again, it couldn't have given us 0 here. So there are certain situations whereby the same value is not giving you 0, then that means to say it is no longer a factor. So repeating this allows us to know how many times that answer is the solution, for how many times is that true. So we are solving, so we are going to solve and we are going to factorize. So to solve this, we are going to have our x squared minus our 4x plus our 13. We are going to find that we cannot factorize this. So let's use the quadratic formula. So our x is equal to plus or minus the, we have negative b plus or minus the square root of our b squared minus our 4ac. Then we have over our 2a like that. So what we are going to get is that we are going to get a, so in a quadratic equation, the one with x squared, that's your a, this is your b, this is your c. So we are going to have our x is equal to negative, our b is equal to a negative 4. Then we have plus or minus the square root of our b squared, which is our negative 4 squared. Then we have minus 4. Then we are going to have our ac like that. So we have our a is equal to 1, then our c is equal to 13 like that. So what we are going to have, we are going to divide this over our 2, our a is equal to 1. So we are going to have our x is equal to negative times negative, that's positive 4. Then we have plus or minus the square root of negative 4 squared, it will give us 16 since it's in brackets. Then we are going to have minus our 13 minus our, so our 13 times 4, this will give us 2, remainder 1, 4 by 1, that's 4 plus 1, that's a 52. So we are going to have a negative 52 like that. Then we have over our 2 like that. So what we are going to get is that we are going to have our x is equal to 4 plus or minus the square root of, when we subtract our negative 52 minus 16, this is giving us a value that is equivalent to 6 there. Then we have a negative 36. So our value here, it will be negative 36 over a 2 like that. Then what we are going to have is that it's either our x is equal to 4 plus or minus the square root of negative 36 is equal to a 6i. Then we are going to have over our 2 like that. So all we have to do is say x is equal to 4. We can split this over 2 plus or minus 6i over 2. So the 2 can divide both values like that. Then we are going to have our x is equal to 4 divided by 2. That will give us a, so we have a 4 divided by 2, that's a 2 plus or minus 6 divided by 2, that's a 3. Then we have I. So either our x is equal to 2 plus our 3i, or we have our x is equal to a 2 minus a 3i like that. So this is how we find values. So we have found that x is equal to 1 and our x is equal to 1. So at 2 points x is equal to 1, then these are the other values that we have found. So that is how we go about that. So this is solving. Now let's say you are doing what's this? You are factorizing. So if I was to take this value here, what we are going to have is that a negative there, so it will be our x minus the all of these numbers. When they go there, just put them in brackets. It will be a 2 plus our 3i like that. Then we also have when we take x minus, when we take it this side, we are going to have minus our 2 minus our 3i like that. So this is what we have as our values. Let's just factorize the equation, then we can end there. So what we have is that we have x to the power of 4 minus 6x to the power 3, then we have plus 22x to the power 2, then minus our 30x, then we have plus our 13 should be equal to, we have our x minus 1 like that. So now we have our x minus 1 like that. So let's just put it here so that we have enough space. So we have our x minus 1 and our x minus 1. Then the other factor is such that we have our x minus open brackets our 2 plus our 3i. Then the last one is equal to x minus 2 minus 3i like that. So these are the factors that we have. So these are our factors that we have. So this is how we do, or rather that this is how we deal with the factors in that way. So this is how you can factorize the equation provided in that form. Thank you very much for watching. Hope you would like, subscribe and share for more. See you in the next tutorial.